Okay, let's back to the discriminant analysis. It could be linear, just like this example. You find a linear function. You can separate the sample into a class 1 or class 2 or male object or female object. But if you may have to collect the data like this, okay? And in this case, there's no way you can use linear function to separate, right, the sample from class 1 and class 2. So for this case, you need to apply a non-linear function in this case. Okay, so I will talk about how to apply the linear and non-linear. Well, actually, SVM, support vector machine, is a standard approach, and it can be linear and it can be non-linear. Okay, well, let me set it in advance, but you will learn more. Well, for non-linear SVM, actually, it just do the projection. You will project the non-linear, okay, into, for example, into linearly separable, let's say, okay? And you need to find a good transformation function that will convert the non-linear separated data point into linearly separable data set in standard SVM. And usually you never know, can you separate nonlinear into linear? For this example, it's very easy to visualize the result. But usually we talk about a very high dimension data set, vector value data. So there's no way you can visualize what's going on here. So you can only just try out this transformation, that transformation, and hopefully, the transformation will convert nonlinear separable data set into linear separable data. That's okay, but anyway, we'll get into that later on. Okay, that's for what you are going to learn about the supervised. Okay, when I say supervised, let me say it again. You have the input and the corresponding output. Okay, corresponding output. And usually the output must be provided by the user. Okay, but so it could be a very tedious job. You need to dabble, okay, for each training sample. Okay. For unsupervised, which means you only have the input, you don't have the corresponding output, which means there's something you don't know what should be the output, or there's no way you can collect the exact output. And then the technique is based on classic, okay, 分清, just 分清, okay, 清晰理论, okay. And the classing, I will talk about the traditional classing, and also I will talk about how to utilize the deep learning, okay, deep learning for classing, especially for unstructured data, okay. If you already have the features, usually you can just go for the traditional algorithm for classing, but for unstructured data, just as I just mentioned, image or time series data, okay, then you might go between the traditional machine learning for feature extraction, and then apply the deep learning. To use the deep learning to extract the features, and then based on the extracted feature, you apply the traditional classing algorithm, okay, to separate the collected data into different groups, and each group will represent some characteristic, okay. That's the basic idea. And now comes to this diagram is more traditional approach. So I put it here. The other new approach. It could be neural network or deep learning, or you can just write down deep learning. Okay, neural network. But it's fine. Just put neural network. Okay. So before the midterm, I will talk about this. Okay, Bayesian theory, parametric, non-parametric. Then I will talk about discriminant analysis. Okay, based on the linear distribution function or non-linear distribution function. Okay. And then after that, I will talk about the ensemble. Okay, random forest is an ensemble technique, which means you won't use one single classifier to make the final decision. Instead, for a given input, you will use a set of different classifiers, and you will combine all the output together to make the final decision. Okay， 好，就是 ensemble 基本上它是这个叫集成，中文叫集成学习了，它会用一个以上的分类器。Okay，and it has been proved. Okay. Ensemble, usually you will give you the better performance. Even it cannot provide better accuracy, but it won't hurt. It won't hurt, okay, your classification or even regression approach. So that's why people love to use random forest or TAP or any other ensemble algorithm, such as AWS. Okay, I will talk about this approach, sequential ensemble and the parallel ensemble. Okay, then you can apply a Bayesian classifier or SVM or even a neural network, okay, as the baseline for the ensemble learning. That's what you're going to learn, okay, other than neural network. Okay, that's what you are going to learn. Okay, in the first half of this semester. Okay, and so anyway, download PCA and ICA. Okay, and bring it to the class next week. And for the deep learning, okay, for the deep learning. There are quite a lot to download, but I will mention that to you later on. But anyway, we'll talk about the autoencoder convolutional neural network. Some of you have learned this a lot, okay? And also, definitely, I will talk about ensemble CN, ensemble, okay, deep learning, okay? And I will talk about the entity embedding, okay? As I mentioned, you have a lot of features. Suppose you have k features. The dimension is k. Now, the value could be a real number. It could be integer. Or it can even categorical data. Okay? For example, the education level. Okay? Education level. What is the education level of this subject? For example, you want to forecast the salary, okay, the annual salary of some object. Then education level could be a very important, okay, feature. Now, how am I going to represent the education level? That is the problem. That's something about feature engineering. Okay, that's one of the feature engineering. The easy way it could be one could be elementary school. Okay, right? For example, and two could be a junior high, and three could be a senior high, and four could be graduate. Okay, graduate student, and or five could be a PhD student, and etc. Okay. Now the other. Now think of this could be a English letter. Then how are you going to represent A, B, C, D, E? especially for the Taiwanese, your ID numbers, we are starting from one capital, right? Ying, right? A could mean what? Was born in Taipei. I don't know. For example, I know X is Penghu. X is from Penghu. Okay, anyway. Now, so the English letter, you need to write down 1, 2, 3, and up to 26. It's not the best way, okay? The other way around is so-called one-hot encoding, okay? For this case, suppose graduate school, I only have 4 levels, okay, of the education. So I might put 1, 0, 0, 0 to represent you only got the elementary school's degree. And I could put 0, 1, okay, to represent a junior, okay, high, and this represent a senior high. No, I should still have an undergraduate, right? Undergraduate and graduate. I should have anyway. Just assume we have just 4 levels, okay? And finally, the last one will be 1, okay? That's it. But to represent the education level, we change it from one single features, 1, 2, 3, 4, to what? To 4 features. So we extend the dimension. Now, let's go back to the English letter. How many dimensions you increase? If we use one-hot encoding, that will be 26. That is a lot, okay? And your classify most of the time will fail, okay? That will be another issue, especially for the feature engineering. How are you going to represent? You have something like this, okay? Okay. For example, your preference or the smartphone you use. 1 could mean Apple, 2 could mean Google Pixel, 3 could mean Samsung. And the order is not important at all. 1, 2, 3. But for the education level, 1, 2, 3, it could mean something, right? It's ranked. So there's a lot of issue how are you going to represent the feature. Okay, it's very important that I will talk about more in the feature engineering. Anyway, I would especially emphasize for entity embedding because it has been proved. For one-hot encoding, if you go for the entity embedding, which means originally you have a 26 dimension for English letter, we can reduce it by using the entity embedding. For example, I reduce it to 4 dimensions. And that will make things easier to train. And this can be done by deep learning. Okay, can be done. I can try to reduce. And usually for entity embedding, you can either go for the convolutional neural network, especially for autoencoder. Okay, for autoencoder, it's a very important topic because autoencoder can help you to extract. The so-called autoencoder is you have the encoder and decoder. Okay. And the good thing about autoencoder is there's no human intervention because, which means you don't need to do any labeling job. The output is the input itself. The output, so what are you going to learn is to learn the so-called hidden variable. And we use this hidden variable to represent the features, so that the user does not have to worry about what should I use, especially for a time series. You might have a time series, okay, signal like this. You might think of what could be the feature. could be the mean, variance, skewness, and a lot of all kinds of features. Okay, but if you go for the deep learning approach, especially when you apply the so-called autoencoder, then the only thing you need to do is just collect the data and make sure, and then the only thing you need to do is just make the output equal to the input. That's it, right? Then your loss function, you will try to minimize the input and the output. That's it. And you let the autoencoder to extract the feature, the most representative feature of the input. That's the good thing about deep learning, especially for unstructured data. Okay, that will be something. So I will talk about this. Okay, autoencoder, convolutional network, and I will talk about how to use the deep learning for anomaly detection. Okay. For this, you cannot tell there's anything wrong, okay? But for this, definitely, this could be a so-called anomaly, okay? That's so-called anomaly detection, okay? Or even you want to identify the mean shift, right? It could be due to the two whales or anything, something parameter has misjustified. Okay, that will be a very important topic. Okay, but anyway, I will talk about what to download. Okay, after the midterm. So anyway, they are all the topic I'm going to talk about. And I put something new here. As I just mentioned, this is up to January this year. Okay, it's that's something. If some of you have taken my machine vision class, you know, my personally in favor of UNet. That's my favorite. Okay, simple and very efficient. So I include that. This the UNet for long, should be a long sequence forecast, okay, long sequence so it can, it based on the historical data and then just focus of what should be the output for the next time step, but instead you will focus a very long term for the next week or even for the next whole month, okay, by using UNet, okay. For that's something, even you learn something from for machine learning, I mean still was learning something new, okay, because for time series data, initially I thought time series data is much easier to handle compared with image, but actually it could be more difficult. For example, to train a good deep learning model, usually you can go for data augmentation, right? 可以用那个资料扩增。Now for image, you can rotate, you can shift. Now comes to the time series data. What can you do about the data augmentation for time series data? Oops. You cannot rotate it. Okay? Some might say you can swap. I don't know. I mean, it could be more difficult compared with image because they have some spatial relationship. But for time series, they have time dependence. You cannot randomly swap or rotate. Of course, you can say you can shift, but a shift is nothing but just it shift the window, right? That's it. So somehow, it could, for some application, it could be more difficult compared to image, but that's my focus why I need to talk about time series, especially for industrial engineering, okay? You will focus a lot of time series data for manufacturing processes, okay? For medical application or even for any IoT, okay? Application, you will collect a lot of sensor signals. Basically, over time, basically they are all in the category of time series data. Okay, that's something I'm going to talk about, and hopefully I can talk about this because it's something new. Okay, especially for the long-term forecast. Okay, and just in advance for your term project, you might think of to use it for what? The stock price forecast. And if it really works, you might get you rich, right? Okay. It might work, I don't know, but you can think of it, okay? And anyway, that's something I'm going to talk about, okay? Let me show the why I cannot open. Yeah, oh. Not running. 31. 30. Oh, okay, good.
You will be rich.
For deep learning, you can divide it into, again, one more time, for deep learning it can be a supervised learning, as I mentioned. You need to provide the input, okay? It could be an image or it could be a time series data or vector value data, but supervised, you need to provide the output, okay? You need to provide the expected output, okay? The supervised deep learning. And also it can be unsupervised. Whenever we talk about unsupervised learning, usually we talk about this model, this architecture, autoencoder, unsupervised because the output is the same as the input, so that you don't need to worry about what should be the expected output, okay? Because we expect the input will be the same as the output. So what you try to learn is the representative, okay, features. Then you can use it. Then after that, you might use the Z to go for the traditional machine learning, for example, a super vector machine, okay? Or even go for the classic, because it will extract the feature for you, for the user automatically, so the user doesn't have to worry about what are you going to extract the good feature, so that it will improve the classification or the regression. Okay? So anyway, the deep learning will. So I will talk about the supervised learning, especially the convolutional neural network. Okay? This recurrent neural network, I will skip that. I don't have a time. Besides, it's not so popular nowadays. I didn't say it is useless, but because it is by nature recurrent neural network, you cannot do it with parallel operation because you need to depend on the time, which means you want to estimate the outcome of FT. You need to wait until you got the output from the previous time step, and then for that, so you will lose the advantage of GPU somehow. Okay. But I didn't say it won't work. Most of the time, we don't have the time. And nowadays, most of the recurrent, it could be just my personal bias, but nowadays, whenever we talk about the time series data, everybody talk about the transformers. Okay? They prefer to use transformers. So that's one of the reasons. So anyway, I will focus on the convolutional neural network. I will focus on the autoencoder, and also, if I have time, I will talk about the GAN. Okay, especially for anomaly detection. When I say anomaly detection, which means what? I just train sample from one single class. For manufacturing application, which means I just train or I just collect the normal samples. Okay, there's no defect sample at all. But based on what it has been trained with the normal data, and then I can use it to identify the anomalies. Okay, so I might talk about the game. Okay, and the other branch is reinforcement learning. Okay, 强化学习. I don't have time for that. Okay, but I believe Professor Sun's subclass is quite good in reinforcement learning. Okay, it's a little bit different from all the neural network approach, because for reinforcement learning, usually you need to define the real world. Okay, real world, and what you need to define what is the current state, and then you need to define what should be the action to take based on the current state, and then when you apply the action, and hopefully you can improve the real world. That will be another approach. Okay, of course, some of the block or module still based on convolutional neural network. Okay, or even autoencoded. Okay, format. Okay, that. So anyway, we don't have the time for that, and hopefully, I can script out a little bit of time to talk about transformers, especially transformers for time series data. Okay, I'm going to say something about the transformer. Okay, for time series data. Okay, yeah. But it's no guarantee. Okay, because there are so many topics. But you can find all the material. Okay, from your Hangout. Okay, especially on the transformer. Okay, so that's. Let me show you. If you want to know more, no, it's not here. Here, supplementary. Okay, I provide a lot of additional information. Okay, I provide a lot of additional information. Even for the convolutional nets, it says it's better than the transformer, suite the transformer. Okay, and here's a lot of details information you can take a look. Okay, and even how to handle the missing data with deep learning. Okay, you can find the details information from the supplementary here. Okay, and here the transformer. See that I just put it separately, which means I intend to share with you what is the technique for transformer. Okay, here's a new model called Informer. Okay, which is based on transformer, but especially applying for time series code. Okay, Informer. Okay, so. But before that, definitely I will talk about the transformer. Okay, I will talk about the transformer, how it works, and then if I have time, then we can go for Informer. Okay, Informer for time series data based on transformer, but not the traditional neural network or convolutional neural network. Okay, so that's my intention throughout the second half of the semester. Okay, so any questions so far about the topics I'm going to cover? Oops, I lost my. That's. 我应该带我的老婆。Here the syllabus. Okay. Okay. So as I mentioned here, okay, your TA, okay, will be Carlos. It's pretty good in programming, okay, programming code. Anyway, the class note will be available on the class portal. You can download it, okay. So you need have to download, no matter print out or just download it to your laptop, okay. First part will be PCA and ICA, okay, PCA and ICA, okay. And also, I include some of the reference. Most of the reference have the online, okay. It will be the ebook, okay, available online for free, okay, for free. Such as in the early day, most of my material is based on the webs, okay, textbook, statistical pattern recognition, okay. And here's another textbook, okay, called Dive into Deep Learning. You have 981 pages. There's no way you can go through all the details. But anyway, it's good to have it, all right? It's for free, okay? And the other one will be another ebook, okay? Talk about understanding machine learning, okay? That's another ebook, okay? It's up to you. Okay, anyway, all the material you need is available on the portal, okay? So here's, I already mentioned that, okay, I was studying PCA, ICA, but before that, if I have the time today, I will give you a very quick overview of the linear algebra, because almost no matter for the traditional machine learning or deep learning, it is based on linear algebra, okay? It's based on, so I just give you, just refresh some of the terminology you are going to see, okay, throughout the whole semester, okay? And then, as I just mentioned, we're starting with the traditional machine learning with supervised classification. So the first one will go for the parametric approach and then non-parametric approach, okay? Based on the density estimation, which means we based on the probability, okay? And then we'll go for the discrimination analysis based on linear, okay, and non-linear, okay? Then I will talk about some of the different criteria and how to find the linear discrimination function, okay? And then extend it for non-linear, okay? Again, somehow it's based on the kernel, okay? 好，它是用核函数在做转换的，我会看到那个东西。Okay, another topic is could be very important called logistic. Okay, logistic regression. I mean, most of the doctors they love to use logistic regression. Okay, because it's much more. You can interpret the result. Okay, from compared to deep learning, okay, you might get better result, but somehow you cannot interpret why you get this result. Okay, so anyway, I will talk about the logistic regression. Okay, and then we will come to the support vector machine. Okay, we'll talk about the linear, non-linear. Okay, and also talk about how to use support vector machine. This so-called support vector regression, how to use it for regression, okay? And then we can, I will also talk about the one class SVM, that's for outlier detection, for outlier. One class, which means this SVM, well, it's quite easy to understand. Why, how come you can use a one class SVM? It's simple. You collect the sample from one single class. In manufacturing application, it means each sample represents a normal sample, okay? And then for SVM, you will try to find a minimal circle. Okay, you will find the circle, which means you will find the center and the radius. And everything, every unknown data point, okay, to the center, we have the center here. If the distance is larger than the radius, then I know this unknown object got to be outlier. That's it. Okay, that's it. But based on SVM. When I say based on SVM, which means it provides not just the output result, no matter for classification, for regression, but it provides some additional information to show you why you will reach this decision. You will provide a lot of details information. That's something we need to talk about. That's why I spend quite a lot of time to talk about the SVM. Okay? So after that, I will talk about the decision tree, and then we will extend it to the ensemble, because random forest, okay, or XGBoost, they all based on the decision tree. Okay? Again, it's quite easy to understand, and most of the doctors, they love to use the decision tree to make the decision. Because actually when you go to the clinic to see the doctor, well, what could be the first question of the doctor when you don't feel well? When you see the doctor, what could be his, right? And then you say what? Right? I got a headache, for example. And then we will keep asking. So here comes, when you go see the doctor, you will ask, if you have a headache, yes, no. You got a headache, then you will further ask the next question, right? And then, and so on and so forth. Then you will subscribe the medicine for you to try out. But after 3 days, oh, we still don't feel well, then you come back and you will try another franchise. That's the idea of the doctor made decision. Okay, so that's it's pretty good. But it worked. Okay, it worked. It worked. So I will talk about 2 types of ensemble classification, or actually it can be an ensemble for regression. The other one is quite famous one called ADA-boost, okay, adaptive boost, which means you use it's sequential, okay. For this case, the ADA-boost is what? First, you will find a decision, a discriminant decision to separate, okay? So this is misclassified, right? Right. So next, you will further focus on these 3 and to find another decision, okay, function to further separate the difference. So somehow with this approach, you use a linear, you use the linear decision function to approximate what the nonlinear behavior of the discriminant function. Okay, that's somehow the ADA-boost does. Okay, know what I'm saying? First, you find, so this could be a classified 1, and then you go for the classified 2. And finally, you will combine all the decisions and make your final, okay, assignment. Okay, so that's why it is so-called the sequential ensemble. But for random forest, no, it just give the input. You give the input X, then You go for the tree 1, tree 2, tree 3, and tree 4, for example. By rendering sample the input data set, the sample from the input data set randomly. Okay, so you will train different decision tree. And finally, based on each individual output, then you will combine together to make your final decision. This approach has been proved it won't hurt the accuracy. You may not improve a lot, but it won't hurt if you don't care about the time, okay, to train the model. Then always use in sample, okay? It will give the better result, okay? Even it does not show a lot of improvement, but it won't hurt the accuracy. And it has been proved it will reduce the variation of the output, the variation. Okay, that's some good property for our application. So anyway, I will talk about the eta boost random forest. I may not have the time to talk about XG boost. When you read a paper or you Google the information, most of the report says XG boost is better than random forest. But again, it's my personal bias. When you apply the XG boost, you need to set up a lot of hyperparameters. And that could be, I just keep thinking, it could be the reason so why you can find a better performance. You know what I'm saying? You need to fine-tune the hyperparameter. So when you use a training data set, I always, you have the training data set, okay? Then you train the model. Then you train the model. Then after that, you use the test, the data set, to see if this fine-tuned hyperparameter is good enough or not for the test data set. If the result is not good enough, what will you do? You will go back to further fine-tune the hyperparameter. But in reality, you don't have this opportunity to do the fine-tuning. You know what I'm saying? 你说事实上你那个常常会讲说，在这个，因为你训练好，你说还有测试啊，测试是没学过的，没有问题。可是呢，当你测试的结果不好，你一定会回来调你的参数，这是我要讲的。他一定会回来调你的参数。那参数不好，那再调到最后会不会好一点？一定会好一点。But compare with random forest and XG boost, it contains more hyperparameter to fine-tune, for fine-tuning. But I didn't say don't use XG boost. But I sincerely recommend it. When you decide to use XG boost, try random forest first, okay? Because it's much easier. Basically, you don't have too many parameters for fine-tune. Especially for this one, the only parameter okay, the main parameter, hyperparameter you need to determine is how many trees. The second will be the depth of the tree. That's it, basically. But for XG boost, you need to set up a lot of course, you can use the default value, but always try to random forest. It's good enough, then you can go for XG boost. But based on my own experience, I mean, the improvement is marginal. Okay, basically you cannot see the jump. Okay, from the accuracy of 80% and jump to 95%. No, basically you won't see something like that. Okay, so anyway, that will be covered. Okay, for the traditional machine learning. Okay, and for unsupervised classing, I will talk about K-mean, fuzzy C-mean, DBS, CN, and another very interesting one called spectral classing. Okay, all these tools you can find it from Scikit-learn. Yeah, that's why I talk about it. Okay, then the reason I talk about all these techniques is you got to know how to set up your hyperparameters value. OK， 因为它这里面有很多参数，那要知道你在设什么啊。You need to know what. OK, and then I will talk about the deep cluster. OK, that's a CM-based classing, and also I will talk about how to use the autoencoder for classing. OK, so you will combine both deep learning and the traditional classing technique. OK. The deep learning part usually it works for feature extraction, especially for unstructured data. Okay, once you extract the feature, then you will use the traditional classing, okay, to separate the group, and then you go back to retrain your deep learning model to extract better features, and then to use the new features to do the classing. And just repeat the procedure again and again, and eventually you can use, especially for the deep learning. Especially for the autoencoder, you can try to improve the extracted or represented feature and use the extracted feature to train your classing. And based on the classing result, you take it as the level. You use it as the level. And to retrain your CNN or autoencoder.